Trial and improvement. Trial and improvement is useful when we want to solve an equation, but we don't have an easy algebraic method to find exact solutions. For example, here we have a cubic equation, and if we draw the graph of y equals x cubed plus 3x minus 1, we can see that a solution lies between 0 and 1, as this is where the graph crosses the x-axis. However, unlike a quadratic equation, where we can use the quadratic formula to solve it, with a cubic equation, we don't have a method like this to use. If we want to know a more accurate answer, for example, to 1 decimal place, then we can use trial and improvement. Here's how we approach a trial and improvement question. First, it's always a good idea to draw a table to organise your working. In the first column, we put our values we want to try for x. In the middle column, we can put the value of our expression after we've substituted in our x. And in the last column, we will know if the result is too high or too low. For our first guess, we can go anywhere between 0 and 1. It does not have to be halfway between. However, this is the value that we will use in this example. When we substitute 0.5 in for x, we get the answer of 0.625. Remember, we're looking for the result to be 0, so this result is too high. So now we must try a lower guess. Trying a number higher than 0.5 would not make sense and would lose you marks in an exam. You can choose any number to 1 decimal place between 0 and 0.5. I'm going to choose 0.4. And when we substitute this in, we get 0.264. This is still too high. So let's try another number. This time, 0.3. When we substitute this in, we get negative 0.073, which is now too low. So this means we know our solution lies between 0.3 and 0.4. In the question, we were asked to find the solution correct to 1 decimal place. And both of these numbers only have 1 decimal place, so one of them is our correct answer. To help us decide, let's draw a number line and place our values of 0.3 and 0.4 on it. At the moment, all we know is that the actual solution lies somewhere between these values. The next trial we do will show us which of the values the solution is closest to, and we do this by going exactly halfway between. Our trial, then, of 0.35 will give us an answer of 0.092, which is still too high. So we know that, in fact, the solution only lies in the lower half of the interval. This means that the actual solution must be closer to 0.3 than to 0.4. So our answer to 1 decimal place is 0.3.